Today's lesson is on sketching slope fields. So what we're going to do is we will start with a differential equation. dy over dx, we'll start with something simple, is 3x. Sketching slope fields, it gives us a picture of what the original function would be if this is the differential equation. So before we even start sketching, I just want to think, let's take the antiderivative of 3x. It would be 3x squared over 2 plus c. So we don't know what that constant is, but we know that this term creates a quadratic. So it's going to create some sort of parabola. But this c would create that vertical shift up or down. We don't know where it would be. The idea of a slope field is we're going to sketch the slope at all these different points. So if we think of different points, x, y, and then we're going to look at the slope at those points. So let's first think about the point 1, 1. So x is 1, y is 1. Well, in this function, I don't need to worry about the y. I'm just plugging in 1 for x. 3 times 1 is 3. So that means that at this point, 1, 1, I am going to sketch a little dash mark that has the slope 3. So let's think 1, 2, 3 over 1. Okay. So I'm not going to make the full slope. I'm just going to sketch a little tiny slope right at that point. So let's pick another point. Let's pick 1, 2. So the point 1, 2, once again, the y value is basically irrelevant in this one. Okay, you plug in 1. Okay, well, that's also 3. Well, that's going to be true for all of these then. So these will all be like a parallel slope, this whole line here. All right, let's pick some of these points on the y-axis. So all of those points have 0, and then 0, 1, 0, 2, 0, whatever. But if you plug in 0, the slope is 0. So if you're going to graph a 0 slope, we're going to have horizontal lines all throughout here. All right, let's plug in -1. So like -1, 1. -1, 3 times -1 is -3. So let's graph that. So we are at this point, -3, 1, 2, 3 over 1. We'll kind of use that. And if we plug in -1, 2, same concept. This whole column here of points will have that same slope. All right, let's look at this point right here. So that is the point 2, 1. 2, 1, you plug in 2, that's going to have slope 6. So that's a pretty steep slope. And if you plug in -2, we'll have a -6 slope, which is pretty steep, and that will be this whole column here. Okay, so that's as much as I really am going to graph, and what you're going to see is you're going to look for like all these versions of possible parabolas. That wasn't a great sketch, but so you can see there's an infinite amount of possibilities because there's an infinite amount of possibilities for that constant c. So what we're doing is sketching slope fields using the derivative gives you a picture of the infinite possibilities of that antiderivative. All these different vertical shifts of this parabola, 3 over 2x squared. And here is one like fully done. There's like slope field generators online, and this is through Desmo, so you can kind of see all the variations of these parabolas. All right, our second example, differential equation equals x times y. So for our next three examples, we'll be looking at these implicit differential equations. So what we're going to do, we're going to look at pick points. Every point has an x and a y, and then evaluate the slope using our differential equation and sketch so that we can kind of get a picture of what the antiderivative graph would look like. So let's start with 1, 1. Why not? So that point at 1, 1, 1 times 1 is 1. So at this point 1, 1, I'm going to sketch a little slope of 1. Okay, but what if we look at 1, 2? Okay, so 1, 2, 1 times 2 is 2. So that has a little bit of a steeper slope. 1 times 3, even steeper, so these will get pretty steep. But what if we plug in this one? 1, 0. 1, 0 is going to be 0. So I have this horizontal slope. Well, that's going to be true for all of these then. And where else am I going to have slope 0? That would be if I've got 0, 1, 0, 2. So the whole y-axis will have 0 slope. Okay, what if we look down here? So 1, negative 1. 1, negative 1 has slope negative 1. So like this. And then this would go to negative 2, so steeper and steeper. So when you're doing these, making these charts can be helpful, but some of it you can just kind of figure out in your head. This point right here, 2 times 1 is 2, so it's going to have slope 2. This is 2 times 2 is 4, so slope 4. A lot steeper, a lot steeper. And then down here, 2 times negative 1 is negative 2. 2 times negative 2, negative 4. And then let's look on the other side. So negative 1 times 1 is 1. Or negative 1, sorry. Negative 1 times 1 is negative 1. And then negative 1 times 2 is negative 2. Negative 3. All right, what happens here? Negative 1 times negative 1. Oh, that goes to positive 1. And then this goes to positive 2. So you can kind of see the pattern here. So for this, you can kind of, similar to that last one, you can kind of see this like parabolic shape a little bit. And then here you can kind of get an even better image of it when you see all of it. So just a reminder, we're starting with a differential equation, starting with this, and then if we're sketching these little slopes, using this to find our slopes and then sketching the slopes, we're getting a picture of the original function, that antiderivative graph. But we're getting the infinite possibilities because we don't know that constant. So you're just getting like that general shape and we don't know the particular solution. Okay, let's do another one together. And then the last one I might have you try on your own. But we've got dy over dx equals x minus y. So let's make our chart x, y, and then dy dx, our slope. So let's pick a point. Let's say 1, 1. What is 1 minus 1? It is 0. So at 1, 1, we have 0 slope. So where else are we going to have 0 slope? Well, anytime x and y are the same, the slope is going to be 0. So 2, 2, and 3, 3, 4, 4. 0, 0. Okay, let's pick this point here. So this is 1, 0. 1, 0. 1 minus 0 is 1. So this has slope 1. And then, okay, what about this point right here? So that's 2, 1. So 2 minus 1 is 1. Oh, and then 3 minus 2 is 1. So I'm going to have a 1 slope down this whole diagonal. All right, let's get some more points. 0, 1. So 0 minus 1 is negative 1. So here we have the slope negative 1. What about 0, 2? Then we have the slope negative 2. And then as you go up, these slopes kind of just get steeper and steeper. All right, let's keep filling this in a little bit. We're not going to get every point on here, but we'll keep going. This point is 1, 2. 1 minus 2 is negative 1. And that negative 1 slope is going to continue. All right, let's get some of these points right here. So negative 1, 1, negative 1 minus 1 goes to negative 2. Negative 1, 2 goes to negative 3. Okay, so these will keep getting steeper. Okay, I'm just going to fill in a couple of these and we'll kind of see where we go from there. So 1, 3. 1 minus 3 is negative 2. And 1 minus 4 is negative 3. Okay, so these are kind of getting steeper. Let's do 2. 1, 2, 3, 4. 2 minus 4 is negative 2. Okay, so we don't have a full slope field graph here, but we can kind of tell it kind of looks like it's almost doing something like this. Okay, well, let's check out the full slope field. So here, once you see it, yeah, it is kind of doing this and then like this. Okay, here is our last example. dy over dx equals x over y squared. So I kind of want you to try this on your own, but first I want to talk about a couple key things. So if you have your chart, what points are going to cause problems? When is y 0? So 1, 0, 2, 0, and whatnot. You're going to have an undefined slope. So students might want to think, oh, I'm going to draw a vertical line at those. And you might see that sometimes, but really what you're supposed to do is just leave it blank. So there will be no slopes here. But on the y-axis, that would be the point like 0, 1 is 0, 0, 2 is 0. So these will all have horizontal slopes. Okay, so I want you to pause the video and try to get some slopes on your own. And then in just a second, I will post up the answer. So here I have gotten some points. It's not easy to tell, but it kind of is almost like going like this and like this in that direction. So again, some of them are not super intuitive on exactly how it's supposed to look, but I think this one, like I have drawn, it kind of goes like this and it kind of starts to flatten out. As you can see, like the higher you get, like these starting to kind of, the slope is kind of flattening out and it's kind of going that same direction like that. So in this video, we're just kind of practicing how to graph slope fields, but we will kind of look to analyze some slope fields. And if I give you a slope field, can you narrow it down to what function matches up with that? So there's your full video. Good luck with the lesson.